Good evening, everyone. So, today we'll be considering a topic called linear programming. So, linear programming is introduced when one seeks to maximize profit or minimize cost. So, let's say you are producing two things. So, we want to know the number of things you can produce, the number of each of the two products that can be produced to have the maximum profit. Or if you want to go into manufacturing, you want to know the number of products that you can produce out of the two or more products that you have to spend less. So that is what linear programming is really all about. There are two major methods to solving linear programming. The first one is graphical method. So we can apply the graphical method when the number of variables in the problem is just two. But if the number of variables in the problem increases, that is, it increases from being two. If the number of variables is greater than two, it becomes a little bit difficult to solve with the graphical method. So that is when the second method is being employed, which is called the simplex method. But for the sake of this class, the method we are going to consider is going to be the graphical method, which means we are only going to be considering just two variables. So the generalized format of linear programming is given by z equal to c1x1 plus c2x2 plus c3x3 plus, in that order, till you get to cnxn. So which is subject to a11x1, a12x2 plus, in that order, a1n xn less than or equal to b1. So it can be greater than or equal to b1 in some cases. So we'll consider an example. So let us consider this example. A company manufactures two types of products, P1 and P2. Each product uses a lathe and milling machine. The processing time for P1 on the lathe machine is 5 hours, and on the milling machine it is 4 hours. The processing time for P2 on the lathe machine is 10 hours, and on the milling machine it is 4 hours. The maximum number of hours per week available on the lathe and milling machine are 60 hours and 40 hours respectively. The profit per unit of selling P1 and P2 are 6 and 8 rupees respectively. Formulate a linear programming model to determine the production volume of each product such that the profit is maximized. So let us quickly go to the formulation of the linear programming model. So the first thing we need to do is to interpret the question. So from the question, we can see that two products are being produced, which means we are considering just two variables, and the number of constraints to the two variables are just also two, which are the milling machine and the lathe machine. So from the question, you can see that the time taken for product 1 to be produced on the lathe machine is 5 hours, while on the milling machine is 4 hours. While for product 2, it is 10 and 4 hours for the lathe and milling machine respectively. And the unit of each of the products are 6 and 8 rupees respectively. 6 and 8 rupees respectively. And we were also told from the question that the maximum number of hours that can be used on the lathe machine per week is 60 hours, while the maximum number of hours that can be used on the milling machine per week is 40 hours. So moving on to the solution to the problem. So we want to assume that the volume of the product P1 is represented with X1 and the volume of product P2 is represented with X2. So you can decide to represent with anything. So once we can draw this table out, the other part of the question, which is generation of the model, becomes quite easy. So the question asks us to formulate a linear program model to maximize the production volume of each of the products. So remember that we represented the volume of P1 with X1 and the volume of P2 with X2. So we can say we want to maximize Z. So Z is the profit now. So mind you, Z can also be the cost, but in this case, it is the profit. Z equals to 6x1 plus 8x2. So which is subject to the following equations. 5x1 plus 10x2 is less than or equal to 60 because the number of hours cannot be more than 60. So that's why we said 5 of x1, that means 5 hours on the the production volume of P1 plus 10 hours multiplied by the production volume of P2 must be less than or equal to 60. Then the second constraint is that 4x1 plus 4x2 must be less than or equal to 40, where both our x1 and our x2 are greater than or equal to 0. They must not be less than 0. That is very, very much compulsory. So the next thing we have to do now is to try to plot the graph. We've been able to come up with the model. So this is the model. We've actually finished the model. This is the model. So what we want to do now is to solve and know where the product is maximized. So, and to do that, let us call this equation 1 and call this equation 2. So from equation 1, we want to make x1 0 so that we can get the value of x2, and we also make x2 0 so that we can get the value of x1. So let our x1 equal to 0. So if x1 equals to 0, then we have 5 into 0 plus 10x2. We are going to make the inequality sign equality sign is equal to 60. So since this one is gone, we can say our x2 is equal to 60 over 10, which is equal to 6. So we can say the first point on our inequality graph is going to be 0, 6. That is going to be the first point. Then from the second equation, or before we move to the second equation, we have to make x2 also 0. Let x2 equal to 0. So if x2 equals to 0, we have 5x1 plus 10 into 0 it's equal to 60. So, and since this one is already equal to 0, we can say our x1 equal to 60 divided by 5. So we can say that our x1 will be equal to 12. X1 equal to 12. So that one we can call it 12 comma 0. So that is that for the first point, for the first 2 points. So this is what we are going to use to draw the first line, 0 comma 6 and 12 comma 0. So let us try to do the second one here. From equation 2, let x1 equal to 0. So if x1 equals to 0, we have 4 into bracket 0 plus 4x2 equal to 40. So we can say our x2 will be equal to 40 divided by 4, which is equal to 10. So for the coordinates, we have 0, 10. Then also let x2 be equal to 0. So if x2 is equal to 0, we have 4x1 plus 4 into bracket 0 will be equal to 40, just as we have above. So we can say our x1 will be equal to 10 also. So the coordinate of this one is 10, 0. Now let's go on to plot the graph. So to plot the graph, I'll be making use of a software called GeoGebra. So, but you can plot the graph using a graph sheet. So let's move on. So all I need to do on GeoGebra is to just write the equation. Then after writing the equation, I'm going to have the inequality graph. So the first equation is 5x1 plus 10x2 less than or equal to 60. So instead of using x1 and x2, since I already know what x1 and x2 is, I'll just use another variable, which is x and y. So in GeoGebra, all I have to do is to write the equation. So I want to make x1 to be equal to x and x2 to be equal to y. So it will be 5x plus 10y is less than or equal to 60. So as you can see, the graph has been plotted. So looking at this place now, we have the point, our first and second point, what we had the other time. So let me put the point, let me name the point. Sorry. So I'm going back to naming the point. So if I put a pin here now, as you can see on this, you can see that we have 0, 6, which is the same as what we have the other time. Then for the second point, placing it there, you can see we have 12, 0. So coming back, you can see 0, 6, and we have 12, 0. So since the equation is less than or equal to, so this is going to be our shaded region. Then let's impute the second equation. So the second equation is 4x1 plus 4x2 less than or equal to 40. So that will be 4x plus 4y less than or equal to 40. So as you can see, just as we've done the calculation before, just like the calculation we did before, we have 0, 10 and 10, 0. So let us put the point again. Here is going to be 0, 10. As you can see, it is 0, 10 here. Then by the time I put a pin here also, you can see it is 10, comma 0. So looking at the graph, sorry, let me quickly put the point again. 0 comma 10 and 0. Sorry about that. Okay, so we have 0 comma 10 and 10 comma 0. So looking at the graph, you will see that the two lines, the two inequality lines intersected at a point, which is the first thing, and you can see that the shaded region also overlaps at a particular point too. So the shaded portion, where the two shaded portion overlaps, is our point of interest. So mind you, remember that our x and our y must not be less than 0, because according to the equation, we said x1 and x2, which is our x and y, must be greater than or equal to 0. So what that one simply means is that from this point to this side, it is not needed, and from this point downward, it is also not needed. So the only portion that we need will just be from here to here. Then that's the first one. Then we also need another one here. Then another one is going to be here. Yeah. Then finally, yes. So this is what we need. This is what we need. So every other part apart from this portion, we don't need it. So on your own graph too, you are going to get something like this, provided you do it correctly. So what we now want to do, since the question asks us that we want to maximize the profit, you see all these corner points, this point A, point E, point D, point F, we are going to substitute them inside the equation of our profit, our Z. So we said Z equals to 6x1 plus 8x2. So after substituting those points, we now check which one is the highest. So at that particular point, that is when we have our maximum profit. So let us write the equation here. So going back, we can see that our point A falls on 0, 6. So let us substitute point A now. So let's call that one Z of A. Z of A. So is equal to 0, 6. So that's 6 into bracket 0 plus 8 into bracket 6. That's 6 times 0, 0, 8 times 6, 48. So 48 rupees. So that means if we decide not to produce product 1 and we produce 6 of product 2, is going to give us 48 rupees. That's the first one. Then for the second point, we need to find our Z of E. That's when both are 0. If we are not producing anyone, that means we are not going to have any profit. Our Z of E is equal to 6 into 0 plus 8 into 0, which is equal to 0. Then the next point is our point D, and our point D is 10, 0. 10, 0. So Z of D equal to 6 into 10 plus 8 into 0. which is equal to 60 rupees. So for the last point, which is the point of intersection of our equation 1 and 2. So um according to the graph I have here, point F is 8,2, but to calculate it manually, what we have is we just have to equate the two equations. Equation 1 is 5x1 plus 10x2 equal to 60. We are changing it to equation now. Then equation 2 is 4x1 plus 4x2 equal to 40. So solving the two equations simultaneously, we get our x1 to be equal to 8 and our x2 to be equal to 2. So that is our point of intersection. That's 8, 2. That's Z of F. So here now we can now say Z of F equal to 6 into bracket 8 plus 8 into bracket 2. That's 48. 48 plus 16, which will give us 64 rupees. So which means to maximize the profit, to maximize our profits now, to maximize our profit, eight of P1 needs to be produced, while 2 of P2 needs to be produced. So that's just the simple conclusion, because at point F, which is 8,2, that is when we have the highest profit. So that is just that about that. So we'll be considering another example again. Okay, the second example. A nutrition scheme for babies is proposed by a committee of doctors. Babies can be given two types of food. We have type 1 and type 2, which are available in standard packets weighing 50 grams. The cost per packet of this food is 2 rupees and 3 rupees respectively. The vitamin availability in each type of food per packet and the minimum vitamin requirements in each type of vitamin is summarized in table 16.2. Develop a linear programming model to determine the optimal combination of food type with the minimum cost, such that the minimum required vitamin in each type is satisfied. So if you look at this question, you can see that the table has already been given, so we need not trouble ourselves about coming up with the table or generating the table. So from the question, you can see that we have two types of food and we have two types of vitamin in each type of the food. So the food type 1 has 7 of the first vitamin, has 1 of the first vitamin and 7 of the second vitamin, while the food type 2 has 1 of first and second vitamins respectively. So, and you can see that the cost per packet is 2 and 3 rupees respectively, while the minimum vitamin requirement, the minimum, which means it can be equal to that minimum or greater than that minimum. So this is an example of a model that has one of the constraints greater than or equal to minimum. So you need to take note of that particular word minimum. So it is very important. That means it can be greater than it, or it can be directly equal to it. So since we are dealing with cost now and not profit, so what we want to do is to minimize cost. So that means that for us to minimize cost, our Z is going to be minimize, not maximize. So we are representing the number of packets for food type 1 to be x1, while the number of packets for the second food type to be x2. So the linear programming model is this. What we want to do is minimize. So we want to minimize z equal to 2x1 plus 3x2. Then the cost minimization is subject to the first equation, the first constraint, x1 plus x2 is greater than or equal to 6, since 6 is the minimum. Then we have 7x1 plus x2 is greater than or equal to 14, bearing in mind that the number of packets for each of the food cannot be less than 0. So it cannot be negative. The minimum we can have is 0, while the maximum can be anything. So just as we've done for the other question that we had the other time, we are also going to do for this one. So we call this one equation 1, then we call this equation 2. So let's divide our space into 2, don't mind my line. So from equation 1 now, from equation 1, let x1, let x1 be equal to 0, which simply means that our x2 is equal to 6. So that's 0, 6. So from that same equation 1, let x2 equal to 0, which means our x1 is equal to 6 also. That's 6, 0. That's that for equation 1. Then for the second equation, from 2, let x1 equal to 0. So if x1 equal to 0, x2 will be equal to 14. Then let x2 equal to 0. So from the first one, we can say it is 0, 14. Then let x2 equals to 0. If x2 equals to 0, x1 will be 14 divided by 2, which is equal, divided by 7 rather, which is equal to 2. So the other one will be 2, 0. Now that we have the points required to plot our graph, let us once again go back to plotting of the graph. So to plot the graph now, we have the first point, just as we've done before. We have x plus y is greater than or equal to 6. Yeah, so as you can see, we have our 0, 6, and we also have our 6, 0, 0, 6, 6, 0. Then for the second equation, we have 7x plus y is also greater than or equal to 14. So yes, now here we have it. And looking at the equation, the graph we have, we can see that it is the shaded portion overlaps on the right hand side because our inequality sign is greater than or equal to. That is it. So the only side we are concerned with now are the positive sides of x and the positive sides of y. So which are from the graph here now, we can see we have 0, 14 here, we have 6, 0 here. So then we also have this particular point here, which we don't know yet. So for the first one, we can just say c equal to what we can see here now is 0, 14. So you can see that point C has been added. Then you can say D equal to, tracing the graph, it is 6, 0, 6, 0. So that's what we have. So as you can see, this is what we have. Then for the third point, we don't know. So just like we did the other time, solving the equations simultaneously, we can also do that. So since we are using a software here, so it can actually snap to that particular point where we need. So as you can see, we have point B to be 1.32, 4.66. So let's try to confirm what we have. Coming back to our where we have our equation. So we want to solve the two equations simultaneously. So the first one is x1 plus x2 is equal to 6, while the second equation is 7x1 plus x2 equals to 14. So if this is equation 1 and this is equation 2, we can just say equation 2 minus equation 1. So which will give us 6x1 equal to 14 minus 6 is 8. So we can say x1 equal to 8 over 6, which is 4 over 3. So, and 4 over 3 is 1.333333. So, which is equal to 1.33. Then for the second part, since we already know x1, so we can say x2 from equation 1. From equation 1 now, we can say x2 equal to 6 minus x1. So that means our x2 equals to 6 minus 4 over 3, which will in turn give us 18 over 3 minus 4 over 3. Remember that 18 over 3 is the same thing as 6. So 18 minus 4 is 14. So x2 equal to 14 divided by 3, which is also 4.67. So 4.67 plus 1.33 is the same thing as 6. So those are the 2 points. So that means our 2 points now are 1.33, 4.67. So that is our point B here. So since what we are dealing with is to minimize cost, so that means the Z we are going to be making use of must be the lowest, the minimum Z. The minimum Z is what we are going to be using. So going back to the graph again, the first one is point C, which is 0, 14. So we can say our z of c equal to, remember the general equation for z is what? 2x1 plus 3x2. Yes. So z of c, 2 into bracket 0 plus 14 into bracket 3. 3 into bracket 14 rather. So which will give us 14 times 3. What is 14 times 3? That's 42, right? 42. So that is that. Then for the second one, we have point D, which is 6, 0, z of d equal to 2 into 6 plus 3 into 0, which will give us 12. Then the third one is z of b. Yes. And our b is 14 over 3 and 4 over 3. That's 2 into bracket 4 over 3 plus 3 into bracket 14 over 3, which will give us 8 over 3 plus 46 divided by 3, which is equal to 50, should be 54. 54 divided by 3, which is 16.67. So looking at the three values that we have, and we know that what we are doing is basically minimizing costs. We are trying to minimize the cost. So looking at what we have here, it is at point D that we can have the minimum cost. So z of d will produce the minimum, will produce the minimum cost. So that is 6 of P1 and 0 of P2. So that is our final conclusion. So that is basically all linear programming entails. So it is where we now have more than two variables that we can employ the simplex method. Simplex method can also be used to solve two variables. So it can also work for it. Thank you. See you next time.